this lesson titled Exterior Angles of Polygons. You will be able to apply formulas for calculating both the measures of the exterior angles and their sum, how much they add up to in any polygon. So our first example is a definition of exterior angles. They are angles formed by the side of a polygon and the extension of an adjacent side. So that's kind of complicated. Let's just see how you draw one and show you where the angles is. So if I take this side and extend it out this way, I start at this vertex and just extend this side out like that, I get an angle on the outside here. This angle right here. This is one of the exterior angles. You know, since it has three interior angles, we can extend all three sides out and get three exterior angles. If I show you the rest of them, now I start at this vertex and go around like this, extend this one past it, we get another exterior angle out here. And then the last one, if I take this and extend it out, I get the third exterior angle right here. And we're going to look at how to find one of them or how to find the sum of all of them, just like we did the interior angles. Got a little different formula though for it. Okay. So again, if you extend that out in your picture or draw this picture in where you can, here are the three exterior angles. So you're going to practice that here again. Draw an exterior angle for each of these regular polygons. So it just says an exterior angle. You can just draw one if you want. So again with the side, take this red. If I start at a vertex and extend the side, go across the side and extend it out, here's my exterior angle. And you could do the rest of them if you wanted. Start at this next vertex, extend it out. We're looking at this angle right here, and so on. So you can do the B one also. Start at a vertex, go across the side and extend it out. Here's the exterior angle right here, and so forth. You could keep doing it. Here's another one right here, and so forth. You could get all of them if you wanted to. Next, we look at the formula for the sum of the measures of the exterior angles of a convex polygon with n sides. So it doesn't matter how many sides it has. What you're doing is adding up. If you add up all of that's what this part of the formula is, add up all these exterior angles, angle 1, angle 2, angle 3, angle however many it has. If it's got 5 sides, it's going to have 5 of these exterior angles, just like it has 5 interior angles. If it's got 10 sides, it's going to have 10 of these exterior angles, just like it has 10 interior angles. And they always add up to the same amount, the exterior ones. The interior ones, we had that fancy formula. But the exterior angles, no matter how many there are, whether there's 3, 4, 5, 6, they always add up to 360 degrees. So find the sum of the exterior, this example 2, find the sum of the measures of the exterior angles of an undecagon. Well, that's got 11 sides, but it really doesn't matter how many sides they got, because this formula says no matter how many exterior angles it's going to always add up to 360, whether it's got 3, 4, or 11 sides. So that's a pretty easy problem. Now we look at a formula for the measure of each exterior angle of a regular polygon. A regular polygon, all the interior angles are the same, and so will all the exterior angles will be equal also. Not to the interior ones, but to each other on the outside. So to find one of them, we take the sum of all of them, which is always 360 degrees, we saw in that last formula, and divide by how many sides there are, how many exterior angles there are. So we take 360 and divide by n, the number of sides. Look at an example of that, and then you find what each one equals. So it says find the measure of one exterior angle of a regular undecagon. So we're going to take the measure of of one of the exterior angles will be 360 divided by how many sides it has, 11 in a decagon. And this comes out to approximately 32.7 if you round to the nearest tenth. Example 4, you'll be doing some of these in your practice problems. Now we're going to combine the two lessons. You can see at the top of this chart we have interior angles and exterior angles. We saw before the formula for interior, the sum of the interior angles equals 180 times how many sides? A nonagon has 9 sides. 9 minus 2, we subtract 2 from the number of sides and multiply it times 180. And we get 1260 degrees for adding them all up, the sum of all of them. Then the measure of each interior angle, if it's a regular nonagon, we take how many, all of the total measures of all of them, divide by how many angles or how many sides there are. There was 9 sides, so we divide by 9 and we get 140. So there's the interior, the sum of all of them and what each one would be in a regular polygon. Their exterior angles would always, again, add up to 360 degrees. To find one of them, we take that 360, divide by how many there are, 9, which equals 40. Okay? That's not too bad. I'll let you fill out the rest and I'll check it later. Okay? Look up the names if you need to. What's next? It says the measured exterior angle of a regular polygon is 30 degrees. Find the number of sides. We did one of these with interior angles also. So this time they give you the measure of the one angle. They want to know how many sides. So in the formula, the measure of each exterior angle is over here. So we'll put the 30 there. It equals what? The sum of all the exterior angles, which is always 360 degrees, the exterior ones, divided by what? How many sides it has, and that's what we're looking for. So this is how we set up the equation. And similarly, like in the other one, we got that n on the bottom. So what we want to do is multiply, get rid of this division by n, and multiply by n. There is another way to teach you, but this is probably the easiest way. So we multiply this side by n. Whoops. I think I got some mess down here. Let me erase it. Alrighty, back to this. So what does this do? This cancels out the n. On this side of the equal sign, we get 360 degrees. On the other side, we have 30 times n, 30n. And now to get n by itself, to undo this multiplication, we're going to divide by 30. So we get n equals 360 divided by 30. Let's see, it goes in there 12 times. So the number of sides on this polygon that has an exterior, irregular polygon that has an exterior angles equal to 30 degrees, all of them, is 12 sides. Remember, when you're solving for the number of sides, you should get a nice a whole number, no decimals in this, because it's a number of sides. You can't have 12.5 sides or 12.2 sides. Should come out to a nice whole number, or you've done something wrong. And that is it for these notes. Now you're going to go ahead and do the practice problems. Next time I'll probably have while I'm absent, have a quiz for you on interior and exterior angles. So you may use your notes, and have a good day.